So I was extremely displeased last week, and I didn't record it in my videos. And many people may know this ST-70 that I have documented my ST-70 restoration video. It is in its original patina, but the amplifier is completely restored. And what happened is I wanted to use it to show some examples that I was going to do in this restoration of this 012 Heath kit. And what happened is when I plugged it in, this rectifier here lit up like a Christmas tree, right? And during the restoration, and was completely restored to include this brand new electrolytic capacitor. Now usually I don't use these. I leave the old can in and I put a capacitor on the bottom, and most folks know I'm really big about electrolytics. I don't trust them at all, so I'm always big about replacing them. I never leave the old ones in. I'm reserving judgment right now, but I didn't have time to work on this. I ended up using a guitar amplifier and a tablet to do that demonstration. But now I'm coming back to this unit, right? And I want to do some tests. And I haven't obviously haven't plugged it in, right? I'm not going to keep blowing fuses and tubes, but I want to take a look there. First I'm just going to clip off the output and see what's going on, and then I'm going to start dissecting this circuit here, because it's pulling a massive amount of current to do what it did to that vacuum tube. So we're going to have to take a look here and see what the hell's going on. I've isolated the rectifier from the capacitor, and this will allow me to safely check the voltages on the rectifier without having to worry about pulling any excessive current. It is back on the variac, which is on the floor. I can't show, but I'll be able to turn this up now safely. I'm seeing on the tubes on the output around 370. I got the voltage a little bit low on the AC input. So the rectifier seems okay. This is a no-load output, obviously. With it disconnected, it seems to be functioning fine on my other GZ34. I'm going to give a test on the one that flared up and slowly dial it up and make sure that tube is okay as well. This one is also showing the same output given the same voltage. Obviously, we're going to have to see what these look like in a load condition. This is no load output, so we're going to shut down, power down the unit. We're going to take a closer look at that capacitor and see what's going on. So this is a 20-20-30 capacitor. Let's go through and measure them out. So as best as we can in circuit. So we got 20. That's well within tolerance. 22. We got 20. We got 20. Looking good. Yeah. We got 14. That should be 30. Yeah, we got a problem. Wonderful. I'm gonna to be fair. I'm gonna disconnect everything off of this capacitor, completely remove it from circuit, and retest. This portion of the capacitor is now completely isolated from the rest of the circuit. We can properly test this segment now. In removing all of the pieces, the capacitance value has gone up to 22 microfarads. I will note that for the purposes of this testing. All of the checks with the capacitor found it to be in good working order. In removing those connections, I also found I was able to check the other connections to some degree and found those to be in good working order too. I'm going to start working back past the capacitor and see what I find. I've reconnected everything back up as it was, and I'm going to be checking DC power off of here. The difference is I've pulled out all of the power tubes as to have nothing to draw current, and I'm going to be inspecting this bias circuit here, and I'm going to be bringing up on the variac very low amount of rectified power is what I want to see, very low indeed. So I'm not going to allow any appreciable amount of current to be drawn and see what's going on here. And then I'm going to be taking a look to see if there's any DC voltage or negative DC voltage being developed on this bias circuit at all. Okay, I don't have any calibrated AC right now because I'm on the variac and I don't feel like disconnecting this to test. But I think the point is here is that everything is normal back up, right? And got the rectifier in. I'm tapping off the DC coming off the rectifier. Right, so the amplifier is on and it's stabilized because there are no output tubes in the rectifier. There's no sparking or arcing or explosions or anything going on right now, right? So it's something in the final circuit, which I'm not thinking so much just yet, or there's no bias, and these things are literally running away with current. So now that I could have the amplifier running, we take a look at this bias circuit, see if we're getting any voltage on here. I'd hate to think the selenium rectifier died. That would sadden me very much so. No, that selenium is in at 46 and it is out at neg 57 volts DC. Thankfully there's nothing wrong with that selenium rectifier. It is not the culprit. Let's take a look at them voltages coming off there, that capacitor now that we got it in play. Let's see what we got here. All right, so we got that fundamental one that I just showed, right? 298, 382, 439, or 438, right? So we got 438, again, 438. So I've traced the grid bias. You know, I've been looking around. Trying to see what's going on, and I think that the output tubes are drawing excessive current. And I traced this grid bias all the way around. Comes up through here, everything's fine, and makes its way into these potentiometers, right? So I've got this, you know, neg 30. Well, it comes down, and I got this neg 26, and it bridges across, you know, both. And then on the ends of the pot, I got neg 38, you know, and they're bridged too. That's fine. Each of them come out separately for their own network on you know, for each channel, right? And I got channel 2 and or pin 2 and pin 6, and I got garbage, you know, nothing. 2 and 6, and if there's no negative voltage on these right here, there's nothing to hold back current in those EL34s, so they would just explode. So I have to look, and if you look right here, you'll see, you know, 6 comes up, wraps around right here, you know, they make their way across, and they come right out into the tube socket, you know, and they go right to the grid bias. This is a big problem, so we got to look at that. You know, I went and took a screwdriver, a slotted screwdriver, and took it to the pot, and went back and forth slightly just to work it here in Florida. In the last 2 weeks, we shut off our air conditioner, and you know, the humidity did go up in the house, and in that time frame, you know, these pots are the originals. I haven't put this in a new chassis yet, and even though these Deoxit has cleaned this pot, a little bit of humidity, a little bit of gunk in there was enough to take down the bias circuit. And I bet you dollars to dimes. And I'll tell you what, this one I'm going to do on camera. I'm going to break, right? And I'm going to clip this off to this one right here, showing this voltage. And I'm going to do this on camera. I'm going to clip this on. I'm going to go back with a screwdriver and see if we can restore this. So let me set that up. So I'm set up right now. I usually don't do these impromptu things with the amp on, but the adjustment is on the front of the amplifier. This is relatively safe. So I'm going to have the camera held. I'm going to direct it this way, and I'm going to take the screwdriver, and I'm just going to wiggle that pot back and forth and see if a bias just appears on this pin here, pin 21, which is biased for the right channel, and this just be unbelievable. You know, if just a matter of just humidity was enough to take down this entire amplifier, right? So here I am, and I'm coming towards this potentiometer here. I'm trying to anyway while holding the camera, right? And going in the back, and I'm going to wiggle back and forth, and I'm wiggling, and look at that. The bias is just like that. The bias is restored. That's crazy. That's absolutely crazy. Should give some pause if you have an ST-70 with some original pots, or even if they don't have original pots, and you live in an area of Florida like I do, and and it's been sitting a while. You know, even if you think your bias is always adjusted and perfect, you know, you could take down this whole amplifier and who knows what else in here, you know, by having those things run away. Maybe because of the way this is set up, you want to give those pots just a little nudge back and forth to make sure that's a, you know, that's a weak point in this amp. You saw it here on this video, what just happened, that just a little bit of corrosion or whatnot can have all that current, you know, pull through an entire channel. But we're gonna put the tubes back in. We're not gonna dwell on this forever. We're gonna put the tubes back in, and then we're gonna fire it back up, and we're gonna make sure that everything's okay now. Again, we're gonna be tied to the output of the rectifier. In this condition, obviously, as the output tubes heat up, if we have a problem with excessive current draw, as the output tubes heat up, we're gonna watch this voltage. You know, at first it comes up until those tubes up, and we'll watch this voltage quickly start to tank. It's going to drop. We see that voltage start to drop. We immediately shut off the amplifier because so much current is being drawn that the rectifier is not going to be able to keep up. It's going to start to melt down. So let's get started now. I've got the variac on 0, so the AC is on. We're seeing a couple of AC volts trickling in. We're gonna roll this up now. And we're not going to see any voltage till I hit about 70, which we're at. I'm going to let that go just a little higher now. And the rectifier is now starting to produce some DC. Getting a little glow. And I'll point out again that when I do this on the variac, I do not have a calibrated AC output. I mean, I could stop and look every time, but that's not the purpose of this, right? What we want to see is stable DC. So the output tubes are heating up. DC is stabilized. Won't really know for a minute, and I don't know where the bias is right now. I know around 33 is safe as long as we're not pumping any music through it, right? So just safe for testing, and it stays over 340. I know that we're good. I'll bring this up to 110. Yeah, 360 we're definitely okay. So this condition has been alleviated. We're gonna put it back together. We're gonna bias this properly. We'll run a bit of music through it and see how it sounds. Make sure it's okay. Yeah, we're gonna try and bring the bias in. I'm not gonna do a whole wait for it to warm up for an hour and stabilize deal. We're just gonna tweak this bias up on both sides and get this thing going. It's not what you call a no compromise bias circuit design. This thing, you know, if I do one side, it shifts the other side, and it's just a mess. But not Dynaco's best design on the planet for sure. But we get it done. See if I know if that's 162 now. If I go into this side, I bet you this side climbed. Oh, not too bad. Bring this up some. Bring that up to about 1.5. This dropped down 1.57. So I could probably bring this up some, and that probably drop that side. This is how it goes. I'll get it done. This part is like the convergence of two projects into one. Now we're going to test it out, basically. You know, the amp is finished, but I finally get to test it against the newly restored Heathkit 012 with the test I wanted to do beforehand. So the bias is set up. Obviously, it's still drifting, you know, as everything warms up, but it's within acceptable levels for the amount of wattage I plan on pumping through this, which is only maybe 1 or 2 watts. Audiophiles will not appreciate that I'm using my tablet connected to my little 8-ohm test speaker. Only left channel, other side using the short duration 100-watt brick. And let's give it a go, see what we got. Well, it looks like the mystery is solved. I think the most important takeaway in all of this is number one, the correct procedure of how you should troubleshoot when you have a rectifier that starts shooting sparks and going crazy. It's obviously number one, shut it off, right? Shut it off and unplug it. Number two is once you've figured out that you know, you have a correct troubleshooting regimen, you've got it on an isolation transformer, and you've got all your safety procedures, disconnect the rectifier output from the rest of the amplifier, and turn it on in a safe manner that you can make sure the voltages going to the rectifier are correct without the rectifier in there. That is to say, the AC voltages. And once that's established, you could then check the rectifier, because it's disconnected from the rest of the circuit, the DC voltages. And then we said that while it's disconnected, you could then check, obviously very important, this capacitor for capacitance and DC leak down values, and make sure that this capacitor is operating correctly, right? And then we talked about after that, when we determined that this capacitor was correct, and you'll see mine is wiggling. I have a separate ground. It is not ground to chassis. It has a very robust ground that's separate from the one that's used as part of the original setup. That's why, because this is obviously going into a separate chassis. Just wanted to point that out, that this is not a problem. After this, the other issue was what's causing that current draw when there were no obvious issues. It could be that there is no bias on these tubes, because the next thing I did was I pulled out all of these output tubes, and the problem ran away, right? And then I said, well, okay, these tubes are out, and there's no other obvious issues. They must be pulling a lot of current. Why are they pulling a lot of current? There's no grid bias. Why is there no grid bias? I said, okay, maybe the selenium rectifier failed, right? And I checked the selenium rectifier, and there was a negative DC voltage, and I started working that circuit all the way around and back, and made its way all the way to the potentiometer. So what is the chance that both potentiometers failed? Well, pretty good apparently, because neither pot had an output negative voltage making its way into this circuit board. You know, and then we watched on camera, after I had solved for the first one by jiggling it back and forth, restored that negative grid bias. We watched on camera when I took that second pot and looked at the output for the bias, and I turned that screwdriver, and all of a sudden blip, and the ohm meter went, and all of a sudden that negative grid bias appeared, and all of a sudden with that grid bias, it brought these EL34s back into an inappropriate amount of current at idle. And there you go, the amplifier is right back where it was. So the last takeaway from all this is, if you live in an environment or have an amp that has original pots, you know, you're always going to be biasing. If you own an amp like this, you're always going to be biasing this amp anyway. But don't go and turn it on without, you know, if it's been sitting a while, or you live in a very humid environment, or you live in Florida like I do, where you've recently shut off the air conditioner a couple of weeks ago. Who cares if you're going to rebias it? Before you turn on the amp, stick a screwdriver in that slot on both of those pots, and just give it a little tweak back and forth like 10 times, and make sure there's no crud there, and that will guarantee you, at least, or improve your odds, that there's going to be some negative DC voltage there to keep those output power tubes there in check, and you will not have that exploding rectifier like I did. Thanks for watching. You all have a good day. Take care.